Hey there, welcome back to the channel. I'm Brian, and in today's video we're going to be working on the star of what seems like almost every video, board 001. Yep, that's right, it's back. It didn't like just working hard in the mine. It wanted some video time, so we'll get into this. But basically, temp senses 3 and 4 are reporting 0 temp values. All right. So you may have noticed if you look up there across the top, I kind of tried to make things a little bit bigger so you can read the important stuff like the meter values and the power supply values. And I shrank the chips because, I mean, honestly, most of the time you don't need to see that. And if there's something really important on the tester screen, I'll pop it up nice and big for you. So let's go ahead and find out what this chip reads right now. I've got my power supply set to 1944, and here we go. Okay, good news. 65 chips. You can see them up top up there. You can see all the nice green squares. 65 chips reported. That's fantastic. Okay, let's go ahead now and check the temperature values. Well, this is fun. It reads normal values. I'll blow it up on the screen, but you can also see it right there. See, it reads normal values that we would expect. Well, if that's the case, then why is the miner reporting something is not right? Because it would not it wouldn't read sensors 3 and 4. Which is on this side of the board. Well, let me take the board apart. We'll check some actual values and find out if maybe we have an RO value that's not quite up to spec. Oh, wait, stop. Pause. Guess what just happened, folks? No temp. No temp on all of them. Joy. Now here's something, I looked at this yesterday and just decided I wanted to wait a day before I worked on this. If I press that DC start, okay, that's good. At least it works this time. See, it works for a little bit, and then once it heats up, it will report no temp. So I probably have a chip probably before the signal path up here in 11 and 15. Probably another chip over here that's out of spec. So let's go ahead. We'll take this heatsink off first, and we'll look at what the values are on that side of the board. All right. So first thing I see here. This has the old heatsink paste. So we're going to need to go ahead and take this off. So I'll go ahead and pull all 3 heatsinks. We'll get this board into alcohol and get it cleaned up after I do some testing. All right, it does look like we have one nut that has failed. If I check it under the microscope real quick. All right, so it looks like that is actually the old style of soldering. So I will clean it up, strip the solder off of that. Ooh, I'll strip the solder off that, and we'll do it the new and improved way. First things first, though, let's go ahead and do some testing and check the voltage measurements throughout the signal flow, particularly the RO value. I want to make sure that it's 1.8 throughout the system. To do that, we'll go ahead and Put the meter in voltage mode. Take my probes. Sharp pointy one will be on the plus. Black will just go onto the top of the chip. Turn my fan on to make sure we stay nice and cool. Since I'm just measuring this, I'm not going to put it under a microscope. RO on these S17 pluses are the center, right? You got 5 test points. It's always the center. All right, well, there's part of our problem. We've got a 1.6, 1.7 on the RO. That is definitely too low. All right, but it looks good in this in domain 2. It looks like it drops out around chip 6. Let's see what it looks like there. Okay, jump on up here. Okay, getting better. Okay, still low. That is interesting. Oh. Did I imagine that? I would have sworn that I saw 1.8 earlier. Okay, well, let's jump over. It's low there. Ooh. I lost another nut that's got to be fixed. Okay, it's 2. Better, but not great. Still low. Okay. Okay, so it's good. 1.8. They're at between 60 and 61. Okay, it starts to drop off, right? 1.75. So let's find out if I can. Where do we start getting weak? No, tester shut off. Seven, 177, 176, 177, 77, 76. 7.6. So it does. We dropped a little bit when we got into this domain. Because back over here we had, so testing between 61 and 60. We go to 1.8. And we lose about 0.3. So it could be that chip right there. We could have a problem. Let me check the voltages of that. 7.8, that's good. 0.77, okay. Okay, 176. A bit lower than I would like. Wow, see, we're dropping pretty fast. 174. 175, 173. Okay, so about the same. Oh my gosh. See, wow. Okay. Okay, this one's definitely sus. Why did I say that, right? Because, so this is, see, it's 60, 50, 41. So if I check on the RO between 40 and 41, see, I'm getting a difference bouncing around 169, 173. But if I go to the other side, so it goes 41, 42, the tester shuts off. We'll reload it one more time. It's a lot more stable. 74, 73. Alright, so what I want to do, I want to reflow this, and I want to reflow this. So I'm going to reflow chips 41 and 60 and see if that makes any difference. Okay, so kind of interesting. If you notice here, I had some solder balls that came out from underneath the chip. So maybe I didn't have the chip fully seated beforehand, but I'm happy with it now. I'll be honest with you, this chip doesn't, I am not proud of this chip. Solder job looks pretty bad. Okay, 65. Now what I'm really interested in, obviously, are my voltages. So there's the 1.8 we had. If we check on the other side here, 1.78. Okay, that's not terrible. I think it's better than it was. All right, let's just check this one right here. So it's 1.74. Man, see, we're really low by the time we get here. Okay, so I would say that we made an improvement, because I think we were bouncing down into the 1.6s. Yeah. Yeah. Okay, good. So reflow in chip 41 definitely helped. As far as chip 60, I don't know. Let's go back here and look. All right, so with chip 60, now we're going back to 59. Wow, look at that difference. 177. Oh, I guess it's about the same. Now there is definitely a drop through this chip 59. It stays pretty solid at 177. It pops up to 178. But between 59 and 58, we drop 77. Okay, maybe not. Okay. Wow, there is a hot chip under my finger. Okay. So that domain's not doing too bad. Till we get to there. Right? See, 177, 178, right? One 176, 175, 74. Okay, so I'm gonna reflow this chip. That's let's see, what is that? That's 56, and that happens to be the first chip after the temp sensors. So let's go ahead and reflow that chip next. While I'm at it, I'm going to go ahead and reflow chip 55 right here. Alright, I think it's cooled off enough now. For the regular viewers of the channel, you may notice that I'm not actually tearing chips off and replacing chips quite like normal. Well, while I was putting together video footage for the ASIC repair course review that I recently did, I kind of stumbled on something that I saw in a video of Crypto Miner CHR, and I think, hopefully I got it right. He talked about the 3 R's: reflow, reseat, then replace. So I'm really trying to do more reflow work on these chips, especially since we're working with a board where my soldering skills were not so good when I first started working on this board. And also, the folks over at Decentral, if you haven't seen their channel, check it out. They helped and commented some weeks ago about if you got chips with a 0 hash, you really ought to try first reflowing that chip to try. So again, we got 2 different experts in the field saying reflow is the first thing, right? So let's get to it. They're cooled off. Let's find out, do we still have 65 chips? Yay, we still have 65 chips. All right, let's check our measurements, especially down around this area in here where I've been reflowing, right? All right. Go back here to the RO. 1.8, good, that hasn't changed. I'd hope not, since I wasn't working on that. 177, 178, that's kind of where it was beforehand. Got to play musical chairs with my hands. Get down here. 177, 178, that looks good. Test on this side. All right, 176, 175. I just really don't like that. Feel like this is we've got a problem with this chip. Jumping over here, 177, 176, yeah. So it drops there with that chip. 176, 177, 175. So we're still swinging there. But when we get to here, okay, so we're about the same. 174. Oh no, see, we're dropping. Okay, so this one probably needs a reflow, and this one up here I'm just going to replace. I know that the second R is reseat, but I actually ended up reseating that one, I think, when I was heating it up. So we're going to replace, and we're going to reflow. Let's get to it. All right, so for someone that's new to doing this work, what am I looking for? I'm looking for all those lovely little silver beads. All right, when I see those shiny silver beads, I know all the solder is flowing. Okay, so it's definitely cooled off now. Let's run a test and let's see where we are. I broke it. Hmm. 0 chips. Well, that sucks. All right, well, let's do the same thing we were doing, which was measuring. Okay. A2. 7.3. Wow, I really messed that up, didn't I? That's interesting. 799. Good, good, good. 180. I don't know what's going on there. That is really weird. Maybe we need to put some heat in there. Alright, but anyway. Let's come on down here to this one. Okay, I screwed up the chip. Yep, messed up that chip. Because that's the one I replaced. Well, fiddlesticks. I wonder, just curious, can I come over on this side even though I messed up that chip? Can I jump? Yeah, cool. So I can jump all the way to here. At 54. And if I jump to here, I'll get 55. Yep, but if I jump to the next one, I bet I don't get 56. Nope. Nope, don't get 56. I didn't get 55, so I messed up that chip. Alright, let me look at it under the microscope. Alright, let's take the chip off. We'll put another chip on. Maybe I got a bad chip. Alright, let's find out if it's cooled off enough. Hey! 65 chips, it's cooled off enough. Alright, let's take some measurements. That's crazy, right? Look at that. It's back to Happyville. 1.8. 1.76. 1.77, 1.78. Yeah. Dang it. Okay, but let's find out what it looks like over here, shall we? 1.76, pretty solid there. 7.6. 7.6, solid. Remember we had a dropout here. Looks like it's doing the same thing. I'm going to jump over 2 domains. Check and see what I got. Looks like about the same. Jump over 2 more. Now I'm jumping 2 domains at a time. so that I can stay with the signal flowing the same direction. Because remember, the signal flows zigzag back and forth, up and down the board. Okay, so we definitely have the weakening of the signal by now. So if I check one domain over, what I'm actually measuring is coming out, the RO coming out of this chip and heading up the board versus down the board. Or down the screen, right? Okay. Let's go back to here. 7. Okay, yeah. Check on this one. I think I reflowed that chip already because that's 41. Okay. I just want to jump down here and see what do we look like down here. Okay, still about the same, hotter than the 80s. Whew. Okay. Let me see. I'm gonna run a temp check. Ooh, yeah, now the board's nice and toasty. Nope. See that? Here, I'll help you. No temps. So we lose the signal. Now, my question really is like, now that we've got a no temp, we've lost all kinds of stuff. Okay, so we got input voltage. We've lost all voltage. What the hell? So I'm checking here. Let me zoom in on this so you can see it. I'll figure out how to get that back, or the meter values back in a bit. If I check here, right? So if I check on that side, that's coming right out of my power supply. I'm getting the 19.4 volts. But if I check on the other side of the MOSFETs, I'm getting 0 volts. And that's probably why I have no temps. Okay, so I check on this side. I've got 19 volts. Hell, I better, because it's literally plugged. It's literally a direct connection back to my connector here. But I'm not getting it over here. That would indicate we've got a problem in the pick. I think I saw something about this. Oh boy, this just got more fun. Okay, I'm going to shut down my tester. I'm going back to, let me put this back over here. All right, I'm going to go back to regular, just DC start testing, right? Now I've got 65 chips. What the hell, Bill? Yeah, I've got 19 volts on the board side of the MOSFETs, right? So both sides have got 19 volts. And if I check my boost looks good. So that all looks good. So what the hell? So as you're watching this, if you know what it is already, comment down below and say, Brian, you idiot, it's XYZ. All right, well, I let it cool off for a bit and did some reading. And what I'm going to get off the test here. I'm going to see if we can go zoom. Okay, so this is the pick right here, and pin number 2 right there is supposed to have about 3.2 volts. And when it does, that should trigger these guys to turn on. That's at least the way I read it. So if it doesn't, then what they say to do is check the cable and also reprogram the PIC. Well, I can do both, but let's find out if we've got voltage, right? I just want to measure it while it's working. Let me see here. Let me put it back into this mode so you can see it. And I'll build up a new version that lets us zoom in even better. Okay, just FYI, you might foolishly think that that's ground. That is not ground. That's 19 volts. Basically, that's the same thing as right here. Now, if I touch to that little pin right there, wow, I get 29 volts. So that's the voltage that I believe triggers the MOSFET. Okay, so what I'm doing, so you can see this side is the input side, this is the output side, and you see this one right here? So if I touch my negative to ground, touch that one to there, I get 29 volts. Interesting. Touch to here, I should get 19. Yep. And if I touch to here, I should get 19. That is interesting. I'll be honest, I don't know a whole lot. I don't fully understand the way MOSFETs work. Uh-oh. Did you see that? We lost a chip. Now it says chip 64. How many of you guys want to bet it's really not chip 64? Alright, let me show you something else. So I'm going to measure over here. Okay, so I'm measuring pin 2. You're about 3.7 volts. Yeah, buddy. Okay. So we got 64 chips, right? Let's find out if is it really like 64? Nope. See, that should actually jump to 60. It's saying 59, so we know we got a problem there. 49, we got a weak chip somewhere. 39, when you don't get the right number that you should, like this should be 10, 20, 30, right? Alright, so I know I got 30 there, good. But if I go to 40, it'll say 39. So somewhere in here is a bad chip. So let's see, can I get 31? Yeah, let's jump and see if I can get 35. Okay, I'm gonna stop this because it is getting, wow, crazy hot over here. Crazy hot. Somewhere between 30 and 40, I got a problem. Okay, it's cooled off thanks to the fans. Now we got 65 chips. So what gives, man? All right, when this happens and I want to hunt, I go into diode mode, and I'm just going to check the diode values of the 5 points. And I'm going to see just what we got, because something between 31 and 40 is wonky. Remember, when you're doing diode testing, the negative goes on the test point and the positive probe goes on the top of your chip. 1.2, 1.2, this should be like a 0.4. This next one should be 1.1, and then this should be back to 1.2. Yeah, the what is that? The reset RSTI, I think. Yeah, in RSTI. So I guess I always call that reset. That's the one that should read around 1.1. Okay, moving on to the next one. Wow, that's high. Yep, that's too high. Probably the problem. Oh, that is super high. Okay, that's another high one. I have a whole buttload of high values here. Okay. So we've got this whole series of chips that the values are way out of kilter. Looking at these chips, you can tell they've been run hot and beat on. So look at this. You can see. Oh, let me get the zoom in. There we go. Okay, focus. See, all of the copper is gone, right? Now, if I move over to this one, I don't know about that one. But let me go up to this one. Look at this. Copper, all gone. This one, copper, all gone. Copper, all gone. This one, most of the copper gone here. So, yeah, you can see where it looks like this. Yeah. I want to double check these readings, make sure I put my meter on the copper. But I think these chips have just been run too hot. They need to go away. Honestly, it looks like I've got a lot more chips because look at this one right here. It's been run to hell and back. Alright, I know that I said I was going to try to follow the 3 R's, right? Reflow, reseat, and then replace. But I tell you what, considering I know these chips have really been run hot, I'm going to skip all of that because I've got chips that have not been run like that. They're way healthier chips that I can replace for like $1 a piece. So let's do that. Oh, look at that! I took 7 chips off the board, soldered 7 chips back on, and what do you know? It worked. Holy cow. Honestly. That doesn't always happen. Let's put it into temperature test mode. And let's just watch the temps and see how they do. Okay, so it's been running pretty good. I moved the board around on the fan, and by doing that, I could get more optimum airflow on right there where the sensors were, and I'm staying under 70 degrees. It's just sitting there cooling with nothing more than the heat sinks on the back side of the board. So I'm really happy with this. It seems to be staying nice and steady. I'm gonna go ahead and fix the 2 spots. Fortunately, they're easy to get to. I'm gonna fix the 2 nuts that are weak. We'll strip the solder off of it, grind it a little bit, and then we'll put the nuts back in place. Give it a good cleaning, test it one last time, plate it or heat sinks back on, and shove it in a miner. Got the heatsink back on. I put the little air shield back on, and we're ready to test this bad boy for the last time. All right, 65 chips. Good, good, good. Okay, let's go ahead and check the temp sensors again. Okay, we've got all good values. So 38, 39, 38, 40, 37, 41. So the way this sensor or this tester reads it, 2's down here, 4's down here. But in the miner, 2's up here, 4's up here. Okay, it's backwards. I feel like a broken record, but if you know anybody at Team Miner in Thailand, we need to tell them about that. Okay, so look at that. What does that say? Failed to reset, failed to restart pick. That is a problem that I had when all of a sudden we had no voltage on the other side of the MOSFET. The pick would do that. Let me go grab that board. I don't have much time left today. I'm gonna go grab that board and see if I can slap a different pick on there. I'll be right back. All right, good news. I've got 5 picks, 5 fresh picks. So we're good to go. I do think I've got to program them, so we'll do that. These came from Thanos Mining. Just click on the link down below. It says Brian's recommends.tech, and you can get the link to this and all the other, most of the other repair parts I use too. I like Thanos. They do pretty good, except they were the guys that actually shipped the 50 hertz soldering stations over to the school. So they screw up. I don't know whatever happened with that. I don't know how Thanos made it right, but they definitely should have. All right, let's get this off. Let's see, can I do it from here? I'm just gonna zoom in, right? I don't have a Picket program screen. Let's check it real quick. Communicates fine. All right, let's get this back in the miner and let me see what's happening. Well, it doesn't look like we're going to find the temp sensors today. So, fixed one problem, probably still need to go back and measure that RO, right? And to see what's going on. See if I can figure out why, oh why, we have this problem with the sensors dropping out. If you want to see the saga about board 001, there'll be a playlist at the end of the video, so click on that. Thanks so much for watching. If you enjoy these kind of videos, please give it a like. That really helps the algorithm to share it to more people interested in repairing miners. Also, if you aren't already subscribed, be sure to subscribe so you'll know when I put out the next video. Thanks again for watching, and I'll see you soon.